Alright, so now that we have a little bit of knowledge about triangles and congruent parts, such as sides and angles, we're going to apply that to what are called the triangle congruence theorems. So let's take a look at what each of these theorems stands for. So you look like twins, are you? Let's have a little look at their DNA, shall we? Remember back when we talked about what congruent meant? So we saw that word congruent. No? Okay. Remember, it means two shapes that are exactly the same size and same shape. They're like identical twins. Okay, so two people run into each other walking down the sidewalk. They look exactly alike. Are they long-lost identical twins or just a freak coincidence of genetic mayhem? Well, there's a good way to find out. You guessed it, a DNA test will confirm if these two are twins or just scary. The triangle congruence theorems are no different than a DNA test. Okay, well there's less blood and bodily fluids involved, but other than that they perform the same function, confirming identical triangle twins. They are SSS, SAS, ASA, and AAS, and HL, which is only for right triangles only, and we're not going to focus on this one this semester. Huh? Okay. We will look at an example of each before we get into practicing. The first one is SSS. SSS stands for side, side, side. So what it means is that if three sides of one triangle are congruent to three sides of the other triangle, then the two triangles are congruent. It's like a DNA test proving that they're congruent. Take a look. If you know, based on the tick marks, remember tick marks tell you that sides are congruent. AB is congruent to DE because of that tick mark. They have the same matching tick mark. AC is congruent to DF, and BC is congruent to EF. You can say that these triangles are congruent. Triangle ABC is congruent to triangle DEF by SSS. We say given because they have been marked on the diagram like that info was given to us. So if I give you two triangles and I ask you to prove if they're congruent or not, one method is to use SSS. See if all three sides on each triangle are congruent to each other. So the ones on this triangle should match up with their corresponding parts, just like we practiced last week. The next method is SAS. SAS stands for side, angle, side. If two sides of a triangle and the included angle, so included angle is a special word that I want you guys to make sure you get some practice with. The included angle means it's the one between the two sides, and I'll show you what that looks like in the picture. So if two sides of a triangle and the included angle, which means the one between the two sides, are congruent to the two sides and an included angle of another triangle, and they're congruent, then the triangle themselves are congruent. So take another look. AC we can say is congruent to OD. Angle C is congruent to angle D, and CT is congruent to DG because these are all given to us. Here's what they mean by included angle. Since these two sides are congruent, the angle between them is angle C. This is the included angle. Since these two sides are congruent, the angle between them is angle D, because it's in between the two congruent sides. It's included between them. For example, angle T over here is not between the two congruent sides. We wouldn't say this is an included angle. So if you have that information with a side, angle, and a side, you can prove that two triangles are congruent or the same size and same shape. Watch out. If the angles that are congruent are not between the two sides, so here's another example. Notice how the angle is not between the two congruent sides. You have an angle, side, side. Angle, side, side. Look at what that word spells. ASS. This is not a way to prove triangles congruent. So it's not SAS, it's ASS. So don't say ASS, don't use ASS. It is not a congruent property. Don't use SSA either because it's just ASS backwards. So when you have triangles that you're trying to prove congruent, the angle has to be included between the sides if you have two sides. Our next method for proving triangles congruent is ASA. So now that we've cleared up the SAS and the bad word, let's move on to the next one. Angle side angle stands for angle side angle, ASA. If two angles of a triangle and the included side, so again, just like included angle meant between, included side means between as well. It's between the angles. If that's congruent to the two angles and an included side of another triangle, then the two triangles themselves are congruent. So here's more looking for you. I have an angle R is congruent to angle U, which is given to you because the angles are marked with the little arcs. RQ is congruent to UT because they have one tick mark. And angle Q is congruent to angle T because they have two arcs. So if this is all possible, you have angle, side, angle, angle, side, angle. These are triangles that are congruent because they have these matching pieces. Another method is AAS, which stands for angle, angle, side. So it's really just a form of ASA. Think about it. If you have two angles in a triangle, you can always find the third angle using the triangle sum theorem, which means you could take the angles and add them up to equal 180 degrees. We practiced that about 2 weeks ago. If you have AAS, you can find the third A and to get ASA. So fortunately, we don't have to actually do this because it can be as hard as it sounds. So here's an example of AAS. Here you have two angles, angle I congruent with angle L, angle J congruent with angle M, and IH congruent to LK. When you have this information, you're able to prove that these triangles are congruent. So they're congruent by AAS. The last method is hypotenuse leg, but we're not going to cover that this semester, so you can just read this on your own and see if you can understand it. We're not going to cover it this semester. We'll look at it next semester. So great, these really don't get too hard, except sometimes you have to come up with some parts that are congruent, like alternate interior angles, remember that from parallel lines, or shared sides. We will start with some simple examples, and when we get to the little bit harder ones, I'll walk you through how to find the missing pieces. So to the Twinmobile, we're going to do our DNA tests, SSS, ASA, SAS, and AAS, to look and see if triangles are congruent. So try the practice problems and see if you can just identify which ones are which, given the pictures and the markings.